The topic of this problem is mesh analysis, and we're going to work with circuits with independent sources. The problem is to determine the mesh currents in this problem, and we're going to introduce the concept of supermesh in order to do this. We see that we have two independent sources in this problem. We have a 7-volt source on the left-hand side of the circuit and a 7-amp source in the center bottom leg of the circuit. We also have 4 resistors that are associated with the circuit as well. What we're going to do is we're going to use mesh analysis to solve the circuit. So we know that we're going to be using Kirchhoff's voltage law to solve the circuit. We know that Kirchhoff's voltage law tells us that the sum of the voltages around any closed loop at any instant in time is equal to 0. So we're going to use that concept and that law to find 3 equations for our 3 loops that we have in this problem. We identify the 3 independent loops. We'll ultimately have 3 loop currents that we solve for, also known as the mesh currents. So let's first identify the loops or the meshes. That's the first step when you're doing mesh analysis. So our first loop we're going to identify as loop 1. On the left-hand side of the circuit, it has a current I1 associated with it. We have a mesh 2 at the top right-hand side with a current I2 associated with it, and a mesh 3 lower right-hand side with a current I sub 3 associated with it. So those are our 3 meshes. They're independent, and the 3 currents associated with those meshes. So let's look at this and let's try to solve this problem. We're going to first try to solve it and see what we come up with without using the concept of a super mesh. So let's look at the first loop and see what happens when we try to sum the voltages around that loop. Loop 1. Starting at the lower left-hand corner of this loop and traveling around it in a clockwise fashion, we first encounter the 7-volt source and the negative polarity of the 7-volt source, so it's minus 7 volts. We then continue around this loop and we encounter the 1 ohm resistor. It has a voltage drop of 1 ohm, I1, which is a positive current flowing through it, minus I2, which is flowing the opposite direction through the 1 ohm resistor. So it's plus 1 I1 minus I2. Let's continue. So we go down through the 1 ohm resistor and the voltage drop across it. The next one we want to add is the voltage drop across the 2 ohm resistor in the middle of the circuit. It's going to be plus 2 I1 minus I3, which is flowing the opposite direction of I1. We then go down and we encounter the 7-amp source and the voltage drop across the 7-amp source. We don't know what that voltage drop is, so we have to add a term, maybe call it V7-amp for that voltage source, and that's equal to 0. That's our first voltage loop, or our first mesh that we've added up the voltages around, that gets us from the beginning around each element and back to their starting point. If we look at that equation, we see that we have the loop currents I1, I2, and I3, which are unknowns, but we've introduced another unknown, and that is the voltage drop across the 7-amp source. Unfortunately, we can't come up with 4 equations. We have 3 independent equations for loops 1, 2, and 3. So if we try to solve this problem like this, we're going to have more unknowns than we do equations. We're going to have 3 equations from our 3 loops, and we would have 4 unknowns from the way we've worked the problem. So that's not going to work. We can't solve this problem with 4 unknowns and 3 equations. So this brings up the concept of a supermesh. And what a supermesh allows us to do is it allows us to write our 3 unknown, or our 3 independent equations without encountering this voltage drop associated with the 7-amp source. So when we're doing mesh analysis and we have a current source which is shared between 2 loops, we have to use the concept of supermesh in order to solve the problem. Because if we don't, we're always going to have this problem of this additional voltage drop across a current source that we can't solve for. So let's use the concept of a supermesh. And we're going to acknowledge that this first equation, while it's written correctly, isn't going to get us the solution because it has 4 unknowns in it. We only have 3 equations. So we're going to use the concept of a supermesh. So the supermesh is a mesh that allows us to, again, write an equation which is independent of our other two mesh equations, but doesn't travel through our 7 amp current source. So let's start over here with the lower left-hand corner, and let's identify what our mesh might look like. So it may come up here, come around, come down, and we don't want to go through the 7 amp source, so we're going to go around it like this, back to the beginning. So if we travel clockwise around this loop, it will be a loop which is independent of loop 2 and loop 3, if we will, but it gives us this equation that we're looking for. So let's do this. Let's call it loop 1, our supermesh loop, and let's write the equation. So it's the equation for the supermesh loop. Starting at the lower left-hand corner, we have a minus 7 volts. Continuing on, we have the voltage drop across the 1 ohm resistor, which is 1 I1 minus I2. Continuing around this loop, we have the voltage drop across the 3 ohm resistor, which is 3, and then the positive current through this in that direction is going to be I3 minus I2. So it's going to be plus 3 I3 minus I2. Continuing onward, we go down through the resistor on the right-hand side of the circuit. It's a 1 ohm resistor, and it's going to be 1 times I3, which is the current flowing through the 1 ohm resistor. Continuing back to the start, and that's equal to 0. So now we have a supermesh equation that has the 3 unknowns, I1, I2, and I3. So we have this first equation, which is our first independent equation. Now let's go to loop 2 and do the same thing. We're going to sum up the currents, or sum up the voltages around loop 2. So we start again at the lower left-hand corner of loop 2, and we encounter the 1 ohm resistor first. It's 1 I2 minus I1, since I1 is flowing the opposite direction. We come over and we encounter the 2 ohm resistor on the right-hand side of the circuit. It's going to be plus 2 I2. And then we encounter the 3 ohm resistor. So it's going to be 3 times the positive current flowing through this is I2. So it's plus 3 I2 minus I3, because the 3 current in the third loop is flowing the opposite direction. And that's going to be equal to 0. That gets us back to the beginning point. So we have a second independent equation which has 3 unknowns, I1, I2, and I3. So we need one more equation. If we look at loop 3, we're going to have the same problem with loop 3 as we had with loop 1. If this is our loop 3, the first thing we encounter is the 7 amp source. We don't know what the voltage drop is across it. We'd have to introduce another variable, V7 amps. But we're not going to do that. What we're going to do is we're going to look at this current source, and we're going to recognize that that current source, 7 amps, is equal to what? It's equal to I1, which is flowing the same direction as the current source, minus I3. So that gives us 3 independent equations, the one for the supermesh, the one for loop 2, and a constraining equation, which I called equation 3. It's really not loop 3. It's really kind of a constraining equation which relates that current source with the loop currents. So we have 3 equations and 3 unknowns. If we solve for I1, I2, and I3, we get I1 equal to 9 amps, I2 equal to 2.5 amps, and I3 equal to 2 amps.